Hey guys, today we are talking about trig functions at any angle, and we are going to get a little more in depth and add another piece to our unit circle and do some more calculations using our unit circle. So first off, I'm going to take you back to geometry for a minute, talking about special right triangles here. So our special right triangles, we recall, are 30, 60, 90 degrees and 45, 45, 90 degrees. So when we had our special right triangles, we had our short side of our 30, 60, 90, and I'm just going to call that x. It'll work for any number x. And so if the short side is x, then the hypotenuse was 2 times that short side, or 2x. Well, then our long side was the square root of 3 times whatever that short side was. In our 45, 45, 90, that was a little simpler. Both of the legs were the same. So if one is x, the other one is x. And then the hypotenuse was radical 2 times whatever that leg was. Also from that same chapter, we talked about sine, cosine, and tangent. You probably learned about SOHCAHTOA to help you remember how those were related. So thinking back to SOHCAHTOA, sine of 30 degrees. We can use our triangle here. So 30 degrees tells us that we're going to start here and go opposite that angle. So opposite 30 degrees is x over hypotenuse is 2x. So x over 2x, those x's cancel no matter what they are. We get 1 over 2. So sine of 30 degrees is 1/2. Cosine of 30 degrees is adjacent to the 30 degrees, so x radical 3, over hypotenuse, which is 2x. Again, those x's cancel out, and we end up with radical 3 over 2. We also have sine of 60 degrees. So now starting at the 60 degree angle, we look across from that, and we get x radical 3 over our hypotenuse of 2x. So we have radical 3 over 2 when we reduce that. I'm going to jump over to the bottom right here with cosine of 60 degrees and keep with this first triangle. So cosine of 60 is adjacent over hypotenuse, so x over 2x, which is 1 over 2. Notice those just switch places. Sine of 30 degrees and cosine of 60 degrees are the same values. Sine of 45 degrees then, opposite over hypotenuse. Those x's cancel, so I end up with 1 over radical 2. But I can't leave that radical in the denominator. So I need to multiply by the square root of 2 over the square root of 2 to get rid of that square root of 2 in the denominator, and I'm left with 2. 1 times the square root of 2 is the square root of 2. So square root of 2 over 2 is your reduced answer. Cosine of 45 is adjacent over hypotenuse. So once again, we can do all of that math, but it reduces to radical 2 over 2 as well. All right, we're going to relate this back to the unit circle in just a minute, but we're going to talk about some pieces of the unit circle here. So let's say that we have a unit circle with a radius of 1. We want to know some point P, so we're going to call that x, y. Well, if I form a right triangle here, here's my theta. X is going to be equal to, so x is some distance out, and y is some distance up, and that gets us to xy. So x is adjacent over hypotenuse would be x over 1. That's the cosine of theta. Whereas y is opposite over hypotenuse, y over 1. That gives you the sine of theta. So let P, X, Y be a point on the unit circle. The coordinates of P can be written as I'm going to ignore this blank, the cosine of theta, the sine of theta. So that's going to help us as we get into the unit circle here and start to fill in the pieces. Because we just talked about the 30 degrees, 45 degrees, and 60 degrees of the cosine of theta and the sine of theta. So we said that the radius was going to be 1, which means, I'm going to start with my x and y axis here. So which means for this one on the x axis, we have gone out a distance of 1, and we've gone up or down a distance of 0. So that point is 1, 0. We have gone at the top of the y-axis, we have not gone left or right, and we've gone up a length of 1. If we move over to the opposite side of the x-axis, we've gone -1, and we haven't moved up or down. And then if we go down here, we haven't moved left or right, but we've gone down 1. So those are your 4 points on the x and y axis. So then we can start to look at, I'm just going to fill in this first quadrant right now. Those circles that we just filled out. Or sorry, the special triangles that we just filled out. So if I have this triangle right here, my theta, remember, is 30 degrees. So my cosine of 30, if you go back, cosine of 30 was radical 3 over 2. And my sine of 30 was 1/2. You can flip back and double check that. I also have, and I'm going to pick a different color here, this distance, which was a theta of 60 degrees. So my cosine of 60 degrees was 1/2, and my sine of 60 degrees was square root of 3 over 2. Then this triangle in the middle, and I'm not going to draw it because it's getting kind of messy, was a 45-degree angle. So our cosine of 45, recall, was radical 2 over 2, and our sine of 45 was also radical 2 over 2. All right, that's our first quadrant, and that looks like a lot of information to memorize, but I'm going to show you a few tricks to help you memorize that first quadrant in class. But then we have to fill in all of these other quadrants, and that seems like a lot to fill in. But we can use some tricks here to help us fill in those other quadrants. So realize that when we're in this top right quadrant, we have positive, positive as our signs. When we move into quadrant 2, we have a negative x value and a positive y value. When we move into quadrant 3, we have a negative x value and a negative y value. And when we move into quadrant 4, we have a positive x value but a negative y value. That will help you as you start to fill these in. Because we're just looking at reflections here to help us. So if you look at this 30 degree, if we reflect that over, it belongs right here. So we've gone left a distance of radical 3 over 2. That's a negative radical 3 over 2. And then we're still up a 1 over 2. If we reflect the 45, we're here, so negative radical 2 over 2 and positive radical 2 over 2. And then if we reflect the 60 degrees, we're at negative 1/2, and we're still up radical 3 over 2. You can use those reflections then to get you down to the bottom of the unit circle as well. So we've gone left negative radical 3 over 2, then we've gone down 1/2. And then negative radical 2 over 2, and negative radical 2 over 2. And then negative 1/2, and negative radical 3 over 2. And then we reflect that as well over here in quadrant 4, and we get radical 3 over 2 and 1 over 2. And we get, oh, and that's a negative 1 over 2. We get radical 2 over 2, and then down radical 2 over 2. And then we have over 1/2 and down radical 3 over 2. So use those reflections to help you fill it out. All you really need to have memorized is that first quadrant. And again, I'll show you a few tricks that you can use to help you memorize those when we get to class. So then find the point xy on the unit circle that corresponds to each of the following expressions. So, sine of 210 degrees. Well, first off, we have to figure out where 210 degrees is. So 210 degrees is more than 180. So I'm going to draw a unit circle in here to help me out. And it happens to be 30 degrees more than 180. So that means I'm looking at right here, this triangle, which means I'm in this quadrant where it's negative and negative. And then I'm trying to figure out where that point is. And so that point is, if I go back here, happens to be right here. Negative radical 3 over 2 and negative 1/2. That's 30 degrees more than the 180 degrees. So negative radical 3 over 2, negative 1/2. But I only want the sine of 210, and so this is cosine sine. So that means I want this one. So the sine of 210 degrees is negative 1/2. All right, the cosine of negative 210 degrees. So now we have to think opposite direction. So negative 210 means I'm going to go clockwise 210 degrees. So I'm going 180 plus 30 degrees more. So I end up right here. So I'm in quadrant 2, which means it's going to be negative and then positive. So if I go back and look, that's right here. So I have negative radical 3 over 2 and 1/2. And I want the cosine, which is the first one. So I have negative radical 3 over 2 is my answer. All right, then the secant of 9 pi over 4. Well, we're in radians, so 9 pi over 4 is bigger than 8 pi over 4. 8 pi over 4 happens to be 2 pi. So I'm 1 pi more than, or 1 pi over 4 more than 1 whole revolution. So I know I'm at this spot right here, which happens to be radical 2 over 2, radical 2 over 2. That's at 45 degrees, pi over 4. Okay, but the secant. And secant, in this case, is 1 over cosine. So secant of 9 pi over 4 is equal to 1 over the cosine of 9 pi over 4. So cosine then is this first one, radical 2 over 2. So I have 1 over radical 2 over 2, which is 2 over radical 2. And I have to get rid of that radical, so radical 2 over radical 2. Multiply those radicals and I get 2 radical 2 over 2, which happens to just be radical 2, is my answer. Alright guys, that's all I have for you today. If you have questions, come in and see me. Otherwise, I will see you in class.